Hello everyone, welcome back. How are you guys today? Today we are doing here factor theorem and its applications, part 1. And then we will have in the next session, theorem and its applications, part 2. Hello everyone, I'm good guys. How are you today? Okay, so let's start this topic for today. Alright now, so let's starting with the first chapter today, recalling about the remainder theorem. Now what is actually remainder theorem says that let Px be any polynomial of degree greater than or equal to 1 and let A be any real number if Px is divided by the linear polynomial x minus A, then remainder is Pa. Very simple, let Px be any polynomial that is given as, for example, Px equals 3x square plus 2x plus 1, and let's say it is divided by a linear polynomial. Linear means x to the power 1. It is divided by qx. It is given as x minus 1. Then remainder becomes, in this case, remainder becomes p of 1. That is P of A. So it will become here P of 1. By substituting here the value of x as 1 in Px, it would become 3 multiplies 1 square plus 2 multiplies 1 plus 1. It would come as 3 plus 2 plus 1. And this we can solve here, it would become 6. So remainder is coming as 6. That means without actually performing the long division method, we can directly find the remainder here by using remainder theorem. Okay, now next moving on further, recalling about one question. Check whether the polynomial Px equals 3x square plus 11x plus 6 is a multiple of a linear polynomial 3x plus 2. We will use a remainder theorem. So we'll put here, just like in the last example, we have here x minus 1, so remainder becomes P of 1. Here also we will find the value of A. So by putting here divisor, that is 3x plus 2 equals 0. Equals 0, we will get 3x equals minus 2, then x equals minus 2 by 3. So therefore remainder becomes here P of minus 2 by 3. So we will get here remainder that will become P of minus 2 by 3. That becomes 3 multiplies minus 2 by 3 whole square plus 11 multiplies minus 2 by 3 plus 6. And now we can solve this. It would become 3 multiplies minus 2 by 3 whole square. That would become 4 by 9. Then plus 11 multiplies minus 2 by 3, that would become minus 22 by 3. And then it is here plus 6. Now we can solve this. It would become 3 multiplies 4 by 9. It would become here 4 by 3. 4 by 3, and then it is minus 22 by 3 plus 6. Minus 22 by 3 plus 6. 6 can be written as 6 by 1, a rational number, P by Q. Now the LCM is 3 here, of 1, 3 and 3, the LCM is 3. In the numerator it will be 4 minus 22 plus, it will be 18. Now numerator becomes here 18 plus 4, that is 22 minus 22 by 3. It is coming as 0 by 3, that is 0. So we can say remainder is coming as 0 here in this case. So remainder is becoming as 0. Therefore we can say 3x plus 2 is a factor of the polynomial Px equals 3x square plus 11x plus 6. Or we can say the polynomial Px, it is a multiple of linear polynomial 3x plus 2. I can again repeat this. Let's take a very simple example. For example, we have 6. It is divided by 2. Now can we say 6 is a multiple of 2 or 2 is a factor of 6? We can check it by putting here 3 in the quotient and then it is 6. So remainder is becoming 0 here. So we can say here 2 is a factor of 6. Or we can say 6, it is a multiple of 2. It is a multiple of 2. Similarly, in the last expression, polynomial it is given as 3x square plus 11x plus 6 and it is divided by 3x plus 2. Without doing the long division method, we find here the remainder by using the remainder theorem. By putting here 3x plus 2 as 0 and finding the value of x, it would become minus 2 by 3. And then finding here p of minus 2 by 3, it would become here 0. We can say remainder is 0 directly from the remainder theorem. So we can say in that case 3x plus 2 becomes the factor of the polynomial px, or and the polynomial px it becomes multiple of the linear polynomial, that is 3x plus 2 here in this given example. I hope now remainder theorem is all clear with you, everyone. Next is concept is here the factor theorem. What this theorem says that, it says that if px is a polynomial of degree n greater than equal to 1 and a is any real number, then the first point is x minus a, it is a factor of px if p of a equals 0. Second point is p of a equals 0 if x minus a is a factor of the polynomial px. Let me just give you a very simple example. Let's take a polynomial here. It is given as px equals x square minus 4. Here degree of px it is 2, that is greater than 1. And let's say a be any real number, it is given as, for example, 2. Now therefore we will have x minus a, it will become x minus 2. Now we can say according to the first point that x minus a is a factor of px. X minus a or x becomes the factor of this polynomial if p of a or p of 2 it becomes 0. Let's now check this. So p of 2, by substituting here the value of x as 2, it would become 2 square minus 4. It is coming as 0. So we can say by substituting here the value of x as 2 in the polynomial px, the p of 2 it is becoming 0 here. Therefore we can say x minus 2 is a factor of this polynomial px. X minus 2 is a factor of polynomial px. Then we will talk about second point here. pa equals 0 if x minus a is a factor of px. Or the first point is x minus a is a factor of px if pa equals 0. Just converse of each other. So if we have x minus 2 becomes a factor, then p of 2 it becomes 0. Or if p of 2 it is becoming 0, for example, the polynomial is here, p of x it is coming as x square minus 4. Then let's find out where it is becoming 0. It is becoming at x equal to, polynomial is becoming 0. P of 2 is 2 square minus 4, that is coming as 4 minus 4, it is 0. So p of 2 it is becoming 0, therefore we can say x minus 2 becomes the factor. The two statements, they are just the converse of each other. Next we will have remarks here about the factor theorem. Let's see how the remark says here. The first remark is x plus a is a factor of polynomial px if P of minus A equals 0. It is similar like this, for example, by putting here x plus A, the divisor, as 0, and then finding here the value of x, it will become minus A. So we can say P of minus A, the remainder, it becomes 0. You can say factor theorem is just the continuum of the remainder theorem only. The remainder becomes 0. Therefore, P of minus A, it would become 0. Similarly, the divisor is given as AX minus B. Then we can say by putting here AX minus B equals 0. In that case, X would come as B by A. Now putting this value of X as B by A in the polynomial Px, we will get the remainder as 0. That is P of B by A, it would become 0. Similarly, for a third remark here, divisor is AX plus B. Putting here AX plus B as 0, we will find the value of X here, it is coming as minus B by A. Now putting this value of X here in the polynomial Px, it would become P of minus B by A, it is 0. That is some remarks from the factor theorem. Similarly, from the fourth remark we have here, if x minus A, x minus B, this becomes the divisor. In that case, by putting x minus A, x minus B as 0, it would become x minus A, x minus B equals 0. It is coming as x equals A and x equals B. So we can say in this case P of A and P of B, they will become the 0. Just applications of this factor theorem. I can again repeat this. If x plus A becomes the divisor, in that case P of minus A, it would become 0. If AX minus B is a factor, in that case putting AX minus B as 0, finding x, that is B by A. So we will have P of B by A, that becomes 0. Similarly, if AX plus B, it is the factor, by putting that equals 0, we will get here x as minus B by A. Putting this value of x as minus B by A, we will have P of minus B by A, it will become 0. And then if x minus A and then x minus B are the factors, then P of A equals 0 and P of B equals 0. Applications of the factor theorem. One example based on this factor theorem, examine whether linear polynomial x plus 2 is a factor of the polynomial x cube plus 6x square plus 13x plus 10. So the theorem says that x plus 2, by putting here x plus 2 as 0, we will get x as minus 2, and then put this value in the polynomial, it would become P of minus 2, it is coming as minus 2 whole cube plus 6 minus 2 square plus 13 multiplies minus 2 plus 10. It would become in this case now minus 8 plus 6 multiplies minus 2 square, that will be 6 multiplies 4, that is 24, plus 13 multiplies minus 2, that will become minus 26, and then plus 10, it is coming as 24 plus 10, that is 34, and then minus 8 minus 26, that would become minus 34, it is coming as 0. So we can say remainder is becoming 0 here, therefore x plus 2, it becomes the factor of this given polynomial, x cube plus 6x square plus 13x plus 10. And now checking here for if x plus 2 is a factor of the given polynomial, next is qx, it is 3x plus 6. By putting here in this polynomial x as minus 2, we will check it is coming as 0 or not. We will get in this case q of minus 2, it would become 3 of minus 2 plus 6. That is coming as minus 6 plus 6. It is becoming now 0. So we can say again the remainder is coming as 0. Therefore, from factor theorem, x plus 2 becomes the factor of the polynomial 3x plus 6. Or we can say the polynomial 3x plus 6, it becomes a multiple of this linear factor x plus 2 here. Next, we will have some one poll question here. The question is displayed in front of you. Yes. This question is on poll. Find the remainder when px equals 3x square plus 2x minus 1. It is divided by qx equals x minus 1. You can use your remainder theorem and give your final answers. So, here the options are now displayed in front of you. Choose from option 1 or option 2. Is it A 4 or B 5? Yes, starting here to get the number of votes from you people. So now, yes, you can take a little time and calculate. Okay, now results are now shared with you. So we have here almost maximum number of votes. They are going with option number 1 here. Okay, let's check it now. So remainder theorem says that if the divisor is qx equals x minus 1, by putting here x minus 1 as 0, finding here x equals 1 and then put that value in this polynomial, it will become the remainder. The remainder is coming as here p of 1, it would become p of 1. It is coming as 3 multiplies 1 square plus 2 multiplies 1 minus 1. Now we can solve this. 3 multiplies 1 square, that is 3, plus 2 minus 1, it will become now 5 minus 1, it is coming as 4 here. So we can say answer is coming as 4, that is option number A. Let's see how many votes have gone with here option number 1. Almost 74% votes. You are right, you can directly use the remainder and find your answers. Thank you for responses. Next, moving on to the next concept. Example is find the value of k if x minus 1 is a factor of the polynomial x square plus x plus k. Using here the factor theorem, so putting x minus 1 as 0, we will get here the value of x, it would become, now putting this value here in this polynomial, that is x square plus x plus k. So we can say p of 1, it would become 0. And the polynomial is here x square plus x plus k, it would become here 1 square plus 1 plus k. It is coming as 0. Now 1 square plus 1, it is becoming here 2. 2 plus k equals 0. And then k becomes equals to minus 2 here. So again I am repeating this. By using the factor theorem, the linear polynomial it is given as x minus 1. The value of a becomes here x equals 1, a equals 1. So by factor theorem remainder is 0. Therefore p of 1 it is coming as 0. By putting this value of 1 in this given polynomial, 1 square plus 1 plus k, it is coming as 0, and then finding the value of k here. K becomes equal to minus 2 for this given example. Next example in front of us, find the value of a for which x minus a is a factor of the polynomial px equals x to the power 5 minus ax to the power 4 plus 3x cube minus 3x square plus 5x minus a plus 2. Here we have the linear polynomial as divisor. It is given as x minus a. Putting here x minus a as 0. The value of x, it is becoming a. Now substituting this value of x as a in the given polynomial, it would become p of a equals 0. by using the factor theorem, because it is given that x minus a is a factor of this given polynomial. So it will become now a to the power 5, then it is minus a to the power 4 plus 3a cube, then it is minus 3a square plus 5a minus a plus 2 equals 0. Plus 2 equals 0 in this case. Now we have here a to the power 5 minus a to the power 5. It would become now minus a to the power 5, then plus 3a cube, and then it is minus 3a multiplies a square, that would become minus 3a cube plus 5a minus a, that would become here 4a plus 2 equals 0. And now we can find here the value of a. It would become now a to the power 5 minus a to the power 5. It will cancel out here. Then 3a cube minus 3a cube. It will again cancel out here. Remaining with 4a plus 2. 4a plus 2, it will become 0. From this equation we will get 4a equals minus 2, and then a becomes here minus 2 by 4. It will become here as minus 1 by 2 here. Again I am repeating this. So here we have to find the value of a, the linear polynomial x minus a, the divisor here, putting that equal to 0, and this is given as the factor of this given polynomial px. Now we will get here x as a. By substituting the value of x as a here in this given polynomial px, we will get p of a as 0. It will become then a to the power 5 minus a to the power 4 and so on equals 0. And then we will have a to the power 5, and then this a to the power 5 will cancel out. Similarly, 3a cube minus 3a cube, it will again cancel out. We will remain with here 4a plus 2 equals 0. From here we have 4a equals minus 2, and then a equals minus 2 by 4. It will become here minus 1 by 2. The value of a for this given polynomial. Okay, next, moving on to the next example now. Example is here, find the value of a and b so that the polynomial x cube minus 7x square plus ax minus b, it is exactly divisible by the linear polynomial x minus 1 as well as x minus 2. So here we have two factors that are given as x minus 1 and then x minus 2. We can use here the factor theorem and then find two equations and then solve for a and b. First factor is given as x minus 1. By putting here x minus 1 as 0, we will get x equals 1. Now, substituting this value of x as 1 in this given polynomial, it would become p of 1 equals 0. We will get in this case 1 cube minus 7, 1 square plus a multiplies 1 minus b equals 0. Now it will become here 1 minus 7 multiplies 1 square, that will be 7. So it is 1 minus 7 minus b equals 0. From here we will get here a minus b equals 6. 1 minus 7 is minus 6. Minus 6 goes to the right hand side. It will become plus 6. So a minus b is here 6. That is equation number 1. Second equation we will get here by putting second factor is x minus 2. Putting this x minus 2 as 0, we will get x equals 2. And then put this value of x as 2 in the given polynomial. Remainder becomes 0 according to the factor theorem. So we will have here p of 2 equals 0. So here we have now 2 cube minus 7, 2 square plus a multiplies 2 minus b equals 0. Okay, I can use the whiteboard here. Due to space constraint, so Px it is given as x cube minus 7x square. Px is here x cube minus 7x square plus ax minus b, ax minus b, and then we have second factor, it is given as x minus 2. By putting that equal to 0, we will get here x as 2. Putting this value here in this given polynomial, according to factor theorem, remainder becomes 0. So we will have remainder as p of 2, it is coming as 0. It will become now 2 cube minus 7 multiplies 2 square plus a multiplies 2 minus b equals 0. Solving this equation now, it will become 2 cube is 8 minus 7 multiplies 4, that is 28. So minus 28 plus a multiplies 2, 2a minus b equals 0. We will get here 2a minus b equals minus 20 or plus 20, because minus 20 will go on the right hand side, it will become here plus 20. That becomes here equation number 2. Now we have basically two equations in front of us. One equation, it is given as, the first equation is already find out. It is a minus b equals 6. So here we have the first equation is a minus b equals 6. Second is 2a minus b equals 20. Subtracting these two equations, it would become sign change minus. It would become here a minus 2a, that will become minus a, minus b plus b, they will cancel out after subtraction, and then 6 minus 20, it will become here minus 40. Solving this, it would become here a as 14. So getting here a as 14 for this given example, and then finding the value of b. So how we can find b here? By substituting this value of a as 14 in this given equation, that is equation number 1, it will become basically 14 minus b equals 6. From here we will get b will transpose to the right hand side, and then 6 will come here, 14 minus 6. So the value of b it is coming as, it is 8. b becomes 8 here. The value of a is 14 and b is 8 for this given quotient. Quickly again repeating this quotient. So example was find the value of a and b, so that the polynomial, it is exactly divisible by the factors x minus 1 and x minus 2. Using factor theorem, first putting the value of x as 1 in the polynomial, remainder becomes 0. And getting here the first equation, a minus b equals 6. Then substituting here the value of x as 2 by using the second factor here in the polynomial, x cube minus 7x square plus ax minus. We will get the second equation here in this case, that is given as 2a minus b equals 20. And then solving these two equations here, we will get a minus b equals 6. Second is 2a minus b equals 20. Subtracting them and find the value of a and b. A becomes 14 and then b becomes 8. A becomes 14 and then b becomes 8 here. Next we will have one more question on pole now. The question is now displayed in front of you. The question is find whether the polynomial x plus 2 is a factor of the polynomial px equals x square minus 4 by using the factor theorem. Yes or no? You can definitely use the factor theorem and give your answers. The question is now published in front of you in just 1, 2, 3 moments. Okay, it is just now displayed in front of you. Yes, the correct answer is it option option A or option B? I think you have just calculated this or done this on your notebooks. Very quick answers we are getting here. Is it yes or no? Results are now shared with you people. You can definitely see results that the maximum number of votes, they are going with option number 1 here, the factor theorem. Let's check it now. So here we have a point where the polynomial x plus 2 is a factor of px equals x square minus 4 by using the theorem. That means divisor here is x plus 2. Putting that equals to 0. And then finding as the value of x, it would become minus 2. By substituting this value of x as minus 2 in this polynomial, px equals x square minus 4. The remainder is p of minus 2. Let's check it. If it is coming as 0 or not. So p of minus 2 will become here. The value of x will be minus 2. It would become here minus 2 whole square minus 4. It is coming as 4 minus 4, and that is coming as 0. Therefore, we can say the polynomial, it is coming as 0. Therefore, and x equals minus 2. Therefore, x plus 2 becomes the factor of this polynomial. So, it's a yes for this given question. Let's see now how many users have the correct answer. Almost 82% users have given the correct answer for this whole question. Okay, thank you for your answer. Now, moving on to the next question then. The next question is here. Example is using factor theorem. Show that x minus L is a factor of the polynomial x square L minus m plus L square m minus x plus m square x L. Now, find out the value of a here. So, by putting here the divisor x minus L as 0, it would become x is coming out to be L. Now, putting the value of x as L in this given polynomial, let's check it if it is coming as 0 or not. Finding here p of L by substituting the value of x as L. It will be x. It will become L square multiplies L minus m, then plus L square multiplies m minus x. It will be L, then plus m square multiplies L minus L. Now here we have L minus L, it will become 0. So this third term, it will become here 0. Because L minus L is 0, 0 multiplies with m square, that would become here 0. Plus, now, this becomes here L cube minus L m. Then plus, minus L square m, and then plus L square m here minus L cube. Now we can distribute we can rewrite this. It will become L cube minus L cube minus L square m plus L square m, and then this would cancel out. This would again cancel out. So we can say the remainder, it is coming as 0. Therefore, by the factor theorem, x minus L is a factor of this given polynomial x square L minus m plus L square m minus x plus m square x minus L here. Yes, it is a factor. Next we have one more example now. An easy question it was. Just put divisor as 0, find the value of x and substitute this value of x in the given polynomial and then check it. If the remainder is coming as 0, it becomes a factor, otherwise it will not be the factor of the given polynomial. Next example is here. If the polynomial x cube plus ax square plus bx minus 9 has x minus 3 as a factor and it leaves remainder minus 3 when divided by x minus. Find the values of a and b here. That means in this given example, we have to use both the factor theorem as well as the remainder theorem. The polynomial px, it is given as x cube plus ax square plus bx minus 9. One divisor is here, or the one factor is x minus 3. Therefore, the factor theorem p of 3, it would become 0. We will get from this one equation, by putting x as 3, it would become here 3 cube, then plus a multiplies 3 square, and then plus b multiplies 3 minus 9 equals 0. Now you can solve this here. 3 cube it is 3 multiplies 3 multiplies 3, that is 9 multiplies 3, 27, plus a multiplies 3 square, that is a multiplies 9, it would become 9a plus 3b minus 9 equals 0. Solving this now, it would become 9a plus 3b, 9a plus 3b, and then plus 27 minus 9, that would become 18 plus 18 equals 0. From here we will get 9a plus 3b equals minus 18. Again repeating this, if the polynomial x cube plus ax square plus bx minus 9 has x minus 3 as a factor, then we will have p of 3, it becomes 0. By putting here the value of x, it is coming out to be 3 cube plus a multiplies 3 square, and then it will be plus b multiplies 3 minus 9, it is coming as 0. Now 3 cube is 27, and then okay, now here we have 3 cube, it is coming as 27, and then it is plus a multiplies 3 square, that is 9a, plus b multiplies 3, that is 3b, minus 9 equals 0 here. And then we can solve this. It is coming out to be 9a plus 3b, and then plus 27 minus 9, that would be plus 18 equals 0. From here we will get 9a plus 3b equals minus 9, 18, and then dividing both sides by 3. The equation is here, 9a plus 3b equals minus 18. Dividing both sides by 3, it would become 3a plus b equals minus 6. That becomes your equation number 1. And then second is to use here the remainder theorem. It's a long question. Now remainder theorem here leaves remainder minus 3 when divided by x minus 2. That means putting here x minus 2 as 0, we will get the rest of x is 2. Here. Now, putting the value of x as 2 in this given polynomial, it would become, the polynomial is x cube plus ax square then it is plus bx minus 9. Now, putting the value of x as 2 in this given polynomial, the remainder becomes how much? Remainder is minus 3. That is, according to the remainder theorem, it will become now P of, this becomes here Px, and then P of 2, it is coming as, remainder is minus 3 here. Now, putting the value of x as 2 here, it would become 2 cube, then plus a multiplies 2 square plus b multiplies 2, and then minus 9 equals minus 3. Now we can solve this further. It would become 8 plus 4a plus 2b minus 9 equals minus 3. Solving this further, it would be here 4a plus 2b, 8 minus 9, that is given as minus 1, equals minus 3. And now it will become here 4a plus 2b equals minus 3 plus 1, that is minus 2. Again dividing both sides by 2, it would become 2a plus b equals minus 1. That becomes here equation number 2. So we can write this here. Equation number 2 is, it is given as 2a plus b equals minus 1. That is equation number 2. And the equation number 1, it is given as 3a plus b equals minus 6. Now we can solve this by subtracting these two equations, that is second from first. Sign change here. It would become now 3a minus 2a, that is coming as a. B and B will cancel out. 6 minus 6 plus 1, that is becoming here minus 5. The value of a is coming as here minus 5, and then we can substitute the value of a in any of the equations to find the value of b. Putting the value of a as minus 5 in this equation, that is 2a plus b equals minus 1. 2 multiplies minus 5 plus b equals minus 1, and from here it will become now minus 10 plus b equals minus 1, and then b is coming out to be minus 1 plus 10, that is becoming here 9. So a is minus 5 and then b is 9 here. A little long question, but still the application of the factor theorem and the remainder theorem for this given question. Again I am repeating the question here. So if anyone has any difficulty in getting this question, you can just again relook at this example. Example was, if the polynomial x cubed plus ax squared plus bx minus 9 has x minus 3 as a factor and leaves remainder minus 3 when divided by x minus 2 here. Find the values of a and b. Factor is x minus 3. We can put it equal to 0. X is coming out to be 3. Therefore, by factor theorem, we can say p of 3 it becomes 0. So we will get in this case 3 cube plus a multiplies 3 square plus b multiplies 3 minus 9, it is 0. Now solving this, the first equation becomes 9a plus 3b equals minus 18. And then we can divide both sides by 3. We can simplify this as 3a plus b equals minus 6. That becomes the first equation in this case. Next is, we can use the remainder theorem. Remainder is, we are getting here minus 3 when divided by x minus 2. That means by putting here x as 2, in this polynomial, we will get remainder as minus 3. So here we have p of 2, it becomes minus 3. And now we can solve this. It would become now p of 2, that is coming as 2 cube plus a multiplies 2 square and so on. We will get second equation as 4a plus 2b equals minus 2. Then dividing both sides by 2, it would become 2a plus b equals minus 1. That becomes the second equation, and this we have the first equation here, and then we can see these two equations. How to solve this? Subtracting equation number 2 from equation number 1. It is coming out to be a as minus 5, and then putting this value of a as minus 5 in this given equation, that is equation number 2, we will get the value of b, that is coming as b equals 9. So we can say a equals minus 5 and then b equals 9 for this given question. I hope now the concept of factor theorem and remainder theorem is all clear with you people. Next, we will take some more question poll now. The question is given as follows. If px is given as kx square minus 3x plus k, for this question I will just open chat box also. Okay. So px is given as kx square minus 3x plus k. It is given as kx square minus 3x plus k. (3x plus k), and then the factor of this, it is given as x minus 1. X minus 1 is one of its factor. It is given. Now, can anyone find here the value of k by using the factor theorem? If you know the answers, you can just write in here at the chat box. Only answers here. The value of k. Waiting for your answers, everyone. You use the factor theorem here by putting x minus 1 as 0, find the value of x as 1, and then substituting this value of x as 1 in this given polynomial px, and then find the value of k. Okay, now answers are recorded in front of you also. So let's check it now. X minus 1 is a factor. By putting here x minus 1 as 0, it would become x as 1. Now, by putting this value of x as 1 in this given polynomial, that is px, it is coming out to be p of 1 equals 0. Remainder is 0 by using the factor theorem. Then we will get here in this case k multiplies 1 square minus 3 multiplies 1 plus k equals 0. So finding here the value of k, it would become k minus 3 plus k equals 0. And from here we have 2k minus 3 equals 0. So here we have 2k equals 3, and then the value of k is 3 by 2. Thank you for the answers. So the right answer is here k equals 3 by 2 by using the concept of factor theorem here. Next question is now displayed in front of you. The question is given as px equals kx square minus root 2x kx square minus root 2x plus plus 1 here, and then it is given that x minus 1 is a factor of this given polynomial, a factor of this. Now can you find here the value of k again by using the factor theorem? If anyone knows the answer, he can just put in here in the chat box. No poll now for this question. Directly you can just put your replies in the chat box if you know the answer for this. Root 2 minus 1, 32, 45, 2 by 3, root 2 minus 1, 2 by 3, root 2 into 1, root 2 minus 1, and so on. Or 2 by 3 here. Okay, the answer is again recorded in front of us, so now we can check it. So x minus 1, putting here x minus 1 as 0. From here we will get the value of x as 1, and then putting this value of x in this given polynomial. The remainder becomes 0. The factor theorem, so we will get here the remainder as p of 1. It would become 0. Now it is coming as k multiplies 1 square and then minus root 2 multiplies with 1 and then plus 1 equals 0. Now we can find here the value of k. It would become k multiplies 1 square, that is k minus root 2 then plus 1 equals 0. The value of k is coming as k equals root 2 minus 1. The value of k becomes here root 2 minus 1 for this given polynomial here. Now for the remaining time, we will practice more questions now based on the concepts of remainder theorem and factor theorem. Next question is given as, we have to find here whether gx is a factor of px here. That means the first case is px is given as 2x cube plus x square. Px, it is given as 2x cube plus x square, then it is minus 2x minus 1, and gx, it is given as, in this case, x plus 1. Now the question is, we need to find out here whether gx is a factor of px by using the factor theorem. How we can check this? We can put here gx as 0, finding here as x equals x plus 1 equals 0, and then x equals minus 1, and then this value of x we can substitute in the polynomial, and finding that polynomial it is coming as 0 or not. That will define the factor according to the factor theorem. It will become in that case p of minus 1. It would become then 2 multiplies minus 1 cube plus minus 1 square minus 2 multiplies minus 1 minus 1 here. Now we can solve this further. It would become 2 multiplies minus 1 cube, that is coming as minus 2 plus 1 plus 2 and then minus 1. Now minus 2 plus 2 it is becoming as 0. 1 and minus 1 is again 0. The value of the polynomial at this point, x equals minus 1, it is coming as 0. Therefore we can say x plus 1 is the factor of this given polynomial, or gx is a factor of this given polynomial px. Next we will have one more question like this. Here it is given as px equals x cube minus 4x square. So px is x cube minus 4x square, and then it is here given as plus x plus 6, and gx it is given as, in this question, x minus 3. Again, we have to check here whether gx is a factor of the polynomial px or not for this given question. Again, we can use the factor theorem here. So putting here x minus 3 as 0, and then the value of x, it will become here 3. Now Substituting this value of x as 3 in the given polynomial, we can check whether the remainder is it is coming as 0 or not. It would become then p of 3 equals 3 cubed minus 4 multiplies 3 square plus 3 plus 6. Now we can check this here. If it is coming as 0 or not, it will become now 27, then minus 4 multiplies 9, that is given as minus 36, plus 3 plus 6. Now rearranging the terms here, it would become 27 plus 3 plus 6 minus 36. Now we can solve this. 27 plus 3 plus 6, it would become here 36. It is coming as 36 minus 36. That is becoming here 0. The remainder is 0 for this given example. Therefore, we can say that x minus 3 is a factor of this given polynomial, or gx is a factor of this given polynomial here, px. So now time to just conclude our session. So in this session we talked about mainly about the factor theorem and the remainder theorem and some examples related to them. So if you can see the slides here, remainder theorem we started with, okay, divisor just put at equals to 0, find the value of x and put this value back into the polynomial and then find the remainder without using the long division method. Then the factor theorem here, if the remainder is coming as 0 in the remainder theorem, we can say the divisor becomes the factor. That is the factor theorem. And here we have some remarks about it. In these remarks, just put the divisor as 0, find the point, that is the value of x, by putting divisor as 0 and then put that value back into the polynomial. It should come as 0 if divisor is a factor of the polynomial. Next, here are some examples based on the basis of factor theorem and the remainder theorem. Okay then, thank you for today. Bye bye and take care. Keep studying and keep revising mathematics. We'll meet again next week on Tuesday, I think. We'll meet again next week on Tuesday. Thank you for today. Bye bye. Take care and keep studying and keep revising. Bye.